conducted by your coordinator for the quiz, right? Right? You all know that, right? The dry run using Google Form. So I suppose that she already informed all of us that she already posted last 2 days. So everybody, you go and try the dry run. Test for yourself. For example, how you take photo after you write down your answer, right? Then you take picture, how to convert to PDF, and then how to upload into the Google Form using the group. Okay, how you label your password, followed by the name, your ID, and the group. Okay, everyone. So don't forget, I think today is the deadline. Right? You just try a few questions, the answers are there, and then just want to get feedback. If any of you have any problem how to upload and so on, you can just contact your tutors or your course coordinator, or for this DAC, you can tell me now, right? Okay, so those of you at home, if still at home, you're not here, then I hope that you all take note. Okay, you have to do the dry run test. Actually, it's posted into the this lecture group. Okay, anyone don't know how to do that? Where to find it? You ask your friend, or you can inform each other. Right, so this is already week 6. Just don't forget the next week, I think Saturday, right? Next weekend, week 7, your first quiz. So follow the time, okay, follow the time and follow the group. Class rep, any questions before I start? Class rep, any questions? Okay, if don't have, we start. So as per last week, actually we've done quite a lot of probability, starting with the concept. So we cover all these example space, sample, events. Okay, the Venn diagram, right? We talk about that a lot because we have 2 rules. I hope you have done at least some revision. Okay, what other rules are we talking about? Addition rule and multiplication rule, right? So this Venn diagram, nothing new now. I believe everyone have learned this set in your early school, right? We use this concept because we want to represent the events, okay, the circle one, right? Okay, as a set. So there are 2 types of concept in set that we have done before. The first one is union, right? The union, and the second one is intersection. So what's the difference between these 2 concepts of events? If you look back at the set, what you have done before, union means it takes either one of the event at one time. So we use the keyword or here, right? And the formula we use when we apply to what we call this probability, we call it or. So we plus, okay, we apply this in addition rule. For intersections, we have to take the area which is common to both. So here, this is the part that we have to make sure satisfy the event A and also event B. So this is actually called N. N, when you see the word N, means must both happen together. and this apply it to multiplication rule. All right, and after that we talk about all the basic formulas, the very simple formula to calculate probability. Okay, and then after that I apply to the rules or the law. The first one is a complement rule. Okay, I think this is everyone should know this. And then, as I said, addition rule. We have two types here, mutually and non-mutually. So for mutually is both cannot happen together, right? That's why there's a split. When there's a split there, the probability for, or we call it the chances of the both event to happen together is 0. Because this one, the A intersect B is null set. Because if you look back at this concept, there's no intersection point here. A intersect B must equal to a null set, right? So it's written here lah, or empty set. So the probability will not happen. That's why it's 0, and that's why there's no minus here. See the formula? Compared to the non-mutually, you need to minus back this one, because here the probability of A and B happen together is possible. They can happen together, can overlap. Okay, can overlap. That's why the probability here not equal to 0. So you have to minus back here. Okay, because you add both 2 times already, so you need to minus back 1 time. Okay, for multiplication rule, now as I said, when you do a tutorial questions, most questions will tell you whether it's mutually or non-mutually. I'm sure you have done all this exercise, right? Example, and then you start doing a tutorial. You can see that partial question also, they won't tell us whether it's mutually or non-mutually. You have to think carefully whether the two events can happen together. If yes, then what should you do? If no, which formula to use, right? Addition rule just have 2 formulas, very simple. If you do not careful, you use the wrong formula, all right? Yeah. So all this will be done already. The next one is the condition probability. This is the one that is quite important. As I mentioned before, one condition or one event which I call it condition must happen first. Then only another event will happen. So I use this car tire puncture, right? Okay, this is one event happen. Unfortunate event happen, and then the person will be late to work, or skip lecture, right? Or lazy go to study. Anything can happen. So the event A will affect the event B, and what we call this dependent. Remember, I use this word. Dependent. Okay, A depends on B, B depends on A. So because of this, when we apply to multiplication rule, remember we have 2 types, independent and dependent. So I mentioned that if you read the questions and you find that one event can influence another event, then you have to use what? Conditional probability. And still remember the formula? Right? So the condition always at the right hand side. The event will be at the left hand side. And then this is how we write the formula. Okay? So be careful of the condition and the probability event can change one. Just make sure your right hand side is always a condition. And how we know there's a condition? You see the word given that if. You see those in the questions, tutorial, past year, then you know this is conditional probability. Right? So the rest of the example we have gone through more of it. And then this is what I mean. Multiplication rule. If it's no condition, then very straightforward. We call it independent. So we just multiply A and B here. Event happen together is PA times PB. So if the question asks, now when you do your tutorial at past year, you have spotted that a lot of questions ask, is this event independent? Have you ever seen the question? How do you prove the two events are independent? You must prove the left equal to the right. So you take PA times 3PE, the answer must equal to what? PAB. Or if the left and the right answer after the times are not equal to the left, or then not independent. Understand? Okay. So the last one, as I mentioned, is dependent. If dependent, this is more challenging. The condition must come in. So your formula is slightly different. PAB is PA times your condition is A. Or last week I wrote down P and A and B is PB times P. The condition is B. A is to B. So this is the two formula which you can always interchange. See which one you use. If you use PA, then you have to use condition A. If you use PB, your condition is B. I already proved to you, right? When these two multiply, you can get back the A and B. Okay. So that is what we have learned gone through as per last week. Now, today I'm going to touch on tree diagram, and the last one is the contingency table. Okay, now for tree diagram, this one also actually one part, another way to present probability. Okay, it can involve independent, it can involve dependent also. So when you have independent, no problem, you just multiply, right? But if you have dependent, then the condition is important. And one more thing that we're going to learn in this tree diagram is called joint probabilities. What is joint probability? Okay, let me introduce to you what's called tree diagram. It's a graphical aid to help us to visualize. Visualize means we picture the idea, the questions, right? Usually the question can be very long story, so we have to present it into a picture form. We call it graphical aid. Involving combinations of trials. It can be used whenever the probability of each stage of the outcomes is dependent on the previous one. It could be dependent, it could be independent, as I mentioned. So here, I want you to take note of the word stage. So let's say, give you one example. Okay. Now, we call this branch of tree because if you look at the picture, it looks like branches of tree. Right? I'm not sure how many of you have seen this before in your previous study. Some of you may have seen this. So let's say in the question you find it asks you to draw the probability tree. First thing you remember is to draw the branches. Okay. Now let's look at this example. We take a coin, we toss it 3 times. Now take note of the word stage. So each stage will show us the outcome. Now, remember when you toss a coin, right? You can have either head or tail, right? Head or tail. So this is the first toss. First toss means the first stage. Either you get head or tail. So what's the probability here? Half and half, right? The probability get head, half now. Tail, so unless your coin is something wrong. Okay, then you take back the toes, the coin, you throw the second toes. This is called second stage really. Now remember, when you get the first toes is head, you pick up the coin, you throw again, you still can get head or tail, right? Do a simple experiment, everyone. Go back, take a coin and just throw. Very simple. No need to do the experiment, you can imagine in your head now, right? So the second toes also you can get head or tail. Doesn't matter whether your first toes is head or even your first toes is tail. The second time you also can get half, right? Head and tail now. Always fair one. And then you will pick up the coin and throw again the third time. You still can get head or tail, right? So you see, even your first toes is head, second toes is head. Your third time also you can get head. Very lucky, like you. Or head, first time, second time, tail. Sorry, head, but the third time unlucky, you get tail. You still have one. Right now, I want to show you what's the meaning final outcome. This final outcome is called joint probabilities. Everyone, you must write down this. You must show your calculation in exam or in your quiz or whatever. Practice this in your tutorial. So you see here, the first outcome is H, 3H here. Now, if you want to calculate, how do you calculate this? Half times half times half, right? Which is what? 1 over 8. Anyone cannot follow? You times, why we times? Why we multiply? Because this is what? Independent, not independent. Or it is going plus, you plus, you become what? Half plus half plus half is already 1.5. Remember, probability cannot be more than 1. Okay, the second possible outcome, head tail, so HHT. HHT is still the same, half. So it's 1 over 8, right? Okay, now let's look at one more. If your first toes H, second toes now is tail, see these branches are this half, then your third toes is H, so H, also 1 over 8, right? Because each of the probability is 1 over 2. And the last one, HTT, also 1 over 8. Now this is the first part where your first toes is head. If your first toes is tail, you also have 4 combination here, which is THH, THT, all these are 1 over 8, right? Right? Just multiply them. And the last one, very unlucky, tail. Anyone to understand? So after this, when you do your questions, you find this scenario, practice this. So you must look at the possible outcome for each stage. I'm talking about 2 here, sometimes it can be 3. If you have 3 outcomes here, second stage also 3 outcomes, then third stage another 3 outcomes, so become how many? A lot already, right? Oh. Okay, all right, now, so this is your sample space, remember? Your sample space is the list down of all the possible outcomes from HHH up to this one, no? Okay, let's do some questions. Find the probability, find the probability, first one, two tail, probability of 2 tails. Two tails. Then find the probability at least 1 head. Can I give you 1 minute? If you know how to do these 2 questions, the rest of the question, I don't think we have probability because you already catch the. So, what's the meaning 2 tail? Find the probability at 2 tails. Now you see there are 8 outcomes here, right? Your sample space. What's the meaning 2 here, 2 tails? So you have to look at which one. Those have what? Those have 2T, right? 1T can count or not? Cannot. No T also cannot. Exactly 2 tails. So which one got 2 tails? When I scribble this, I'm sure you're okay, but just follow me because I have no choice. I have to explain. This one 2 tail. So the 2 tail one is this one. P, HTT. Any more? This one, THT. And this one, ETH. Any more? Anybody found another 2T? I got 3 here. Is it 3? 3, 3. Okay, so 1 over 8 plus 1 over 8 plus 1 over 8 is how many? plus 1, so 3 over 8. Okay, at least one head. What's the meaning of the word at least? Minimum 1. It could be 2. It could be 3. If there's no head means, so TTT cannot, because these are 3 tail. So other than that, any more there's no head. All the head, right? At least one head, except TTT. Now, you learn the complement rule. Complement rule, right? 60% girls means what? 40% boys, 1 minus. So the easiest way to find at least one head is to take 1 minus no head at all, which will give you at least one head. Right now. So 1 minus P, no H. So 1 minus 1 over 8, that will give you 7 over 8. If you don't believe, you take the 1 head, 2 head, or 3 head at this one. So you add it up, this is 7 over 8 here. Right now. So you get the concept already. Now easier for you to look at the next example. All right, can we start? So I give you time to do it. The answer is here. You want to draw the tree also can. You want to use whatever method you can. Make sure you must know whether it's condition or no condition. Now you have 20 DVDs. Last time we call it DVD. Or more DVD. Right? Okay. Now all the YouTube and so on. Okay, 4 are defective. 16 are not defective. Okay. Find the probability that both are defective if 2 DVDs are selected consecutively one time and then the second time. So if the first DVD you take and then you put it back, replacement. Remember last week I mentioned you take up 1 DVD. Before you take the second one, you put it back. So the total still go back to 20, right? So this one is what? Independent, no condition. You write yourself, okay. Without replacement, so the second time you want to take is 19, right? Minus 5 already. So that means the second event influenced by the first DVD. So this is what? Conditional, right? We call it dependent, no? Okay, this is the answer. If I want to put this into the tree, this is how it looks like. Actually, I want to ask you, don't see the tree, don't see the answer first. Imagine you know how to draw this tree, right? Now the D1, D2 means first DVD spoiled, second DVD not spoiled. The D bar here means not defective, right? So you see the first selection is the first stage. So the D1, first DVD is spoiled. D1 bar means the first DVD not spoiled. Okay, so the first DVD spoiled, how much? 4 over 20, correct enough. Anyone don't understand? Now, to get the first DVD, which is not spoiled, 16 over 20, right? Because 4 spoiled, 16 not spoiled. Okay, this is the first selection, no issue one, definitely over 20. But if you look at the second selection, here you have to see whether it's a replacement or without replacement. You see, this is without replacement. This is with the replacement. That's why you see we need to show 2 different outcomes there. Right? With replacement means no condition. Okay. So the second selection, first one you get spoiled. The second one you also get spoiled. Remember the total still what? 20, you put it back. So the total no change. But what happened to your second DVD which is spoiled? Why still 4 over 20? Because you put it back, right? So the spot one still 4, no effect. Unless when you do put it back, and you want to take the second time, spot one become 3 already, right? Out of 19. I'm sure you already know that. So this is the answer. Now this is how we read. Probability, remember the general probabilities. Probability, the D1 selected spot and the second DVD also spot. So 4/20 times 4/20. No? Yeah. You must learn how to write the probabilities. So second scenario, first one spot, the second one not spot. You put it back, still 20, right? And the first time you take the spot one, the second one you don't take the spot one. It's 16/20. Okay, all right. Second, or we call it those first selection no spot one. The second time you want to take spot one, no issue, still 4/20 ma. And the last one, even though you take the first one no spot, you put it back, everything still back to normal 20. So you take the second time no spot one, still 16 also, because even you take the no spot one, you put it back, still 16 also. Okay, so this is actually ask you to fill out D1 and D2 where 1/25 or you can write all this stuff. So later we are going to try some questions which you have to answer based on the different probabilities. So this is the steps. Okay, without replacement, quickly go through it. So we have D1, let's say this is the spot 1/20, right? Now you don't replace it back. Everything when you take the second based on 19, straight away over 19. Oh. So if I take the first one spoil, the second one also spoil. So I say 3 already, because you throw away already. First one is spoiled. How about the non-spot one? Not affected, because you take the first one is spot one, also 16/19. No? Okay. Similarly, if the first one you take not spot one, 16/20, and then you throw away the good one. So the second time you take the spot one, no issue, still 4, but out of 19. Only the total affected. The spot one still 4, because the first time you take is non-spot. And however, you want to take the second time also non-spot one, total also affected. The good one also affected, 15 already. Anyone cannot follow. You need your mind to work. Unless I take out the few DVD or few balls and show it to you. Or you have to be think in the mind now. Okay, so these are all your joint probabilities. Now, make sure the total here, right? All these total must equal to 1. Am I right? Whether it's a conditional probability or not conditional probability, the total must always equal to 1 here. Okay. Now, after you understand already here how it works, now introduce this Bayes theorem. Bayes theorem actually, it talk about more than one outcome. So your tree can be very complicated. This is very simple, only 2 and 4 here. Sometimes it can be 3, 3, 3, 4, 4, 4, right? But I think for your level, it's up to 2 or 3. So Bayes theorem actually says that if the two events are mutually exclusive, the sample space of the experiment associated with them, A intersect B is not set, as I said. Okay, and then A or B equal to the sample space, provided the PA and BB are known. So if D is the actual outcome, we can actually do this or show this up in a set form equal to D. Because the D here, you can see here D union D is still D. This is called law of set, right? You don't learn here. If you learn discrete maths, then you can prove A intersect D, union B intersect D. Actually, you can show that it becomes the set D itself. So don't worry about this. It's just to make sure how many experiments you do in one sample space, the total is always equal to 1, and they are always mutually exclusive. Okay. Now, meaning that if I have D is the probability, you see, D is the probability event, A is the condition. And then another probability, D also the same event. Now B is a condition. So now we have two conditions, right? A and B is a condition. So Bayes' theorem says that we can take or we can write down the formula. Probability of D event to happen is actually PA and D union with P, probability of B intersect with D. A intersect D, B intersect D, you union it is actually same as your PD. Now, as I say, we can actually write like this, split them and write the probability form. And then PA and D, remember last week we learned this. A and D is actually PA times D with the condition is A. Remember, if we write A here, this is your condition A. Remember the formula? Remember last week? If I want to find A and B, if I use this PA, I must multiply what? Condition, right? The condition A must be your condition follow. If I use PB here, then this one must be A stroke B. This one you have to remember. This one. Don't ever forget these two. Practice as many times as you can. These two. I find it dependent modification rule very challenging because this one can apply into tree diagram and the table later on. For independent, no issue. Independent just modify only. Right? The condition one is very challenging. A lot of people cannot do this question because they are stuck in this formula. They are very scared about the condition. If you understand properly, I spend more effort on that. Break through it, then no issue. So I want to show you why we need to look at this. So up to here, everybody okay? Okay, now same thing, we plus. This is for A and D. I write like this. Then for probability B and D, remember B and D, we can write what? PB times your event is D, condition must be B, because we use PB here now. So at the end, the probability to get a D here is actually this formula. So I don't care how many conditions you have. To get the D, you must look at the D, the way that you get D, whether in condition A or condition B or condition C, condition D, and so on. So I don't care how many branches are there. To get the D, you must consider all the conditions. So that's called Bayes' theorem. Now, generally, you see this one, PA or D is this one. Remember, PA and D. Remember, these are condition divided by PD. I always divide by conditional probability, right? Now, PA and D, you can write this one, PA times D condition A, right? Remember, PA, this is condition A. So you divide by what? PD is given by this one. Put inside here. So if I have another C, I write down here plus PC. If I use C here, then I times what? D condition C. If I have another event C, so I use condition C. If I have another event D, then you pass again. Event E, pass again. So this one is auto, There are many events there. So here, this one you also need to pass. Okay, now generally the formula looks scary, right? But actually the calculation is all done here. This one. So let's show you how to use this formula. Okay, no need to memorize one. You just need to understand the concept. That's why I say the formula looks like the symbol, very scary, very confusing. But when you look at numbers, the easiest way is understand it through example, because we see number here. All right. Okay, if you're ready now, let's look at this. In a certain college, the girls constitute 60%. So that means the boys are 40%. So we use symbol, remember? Use symbol. So we define the G student as a girl. The probability to get a girl is 60%, 0.6. Okay, so that means the boy is what? 0.4. Any questions? Okay. Now, 25% of the boys and 10% of the girls are studying statistics. What does that mean? If you don't see the answer solution there, imagine, can you write the symbol on your paper? Let's say this is your tutorial question or test. What's the meaning? 25% boys study statistics, which means the gender is boy, and the boy study what? Statistics. So got two events there, right? One is condition and one is event. Which one is condition? Which one is event? If you look at the answer, you see the T is what? Study statistics are. So the condition is boy, gender. Remember, condition at the right. And then this boy studies statistics. This is how we write 0.25. Then the gender is girl, study statistics is 10%. So this is how we write. That means the gender is a condition. Correct enough? How many of you write the other way around? I don't think so. I think the gender is condition, right? Probability study statistics is given 10 and 25. Oh, don't terbalik, everything also terbalik. If a student is selected, if a student is selected at random, determine the probability that the student is a girl. You don't see the answer there. Anyway, there is no answer there. It's just a tree there. If you don't want to see the tree, you just take a pencil and try to write down the symbol here. A girl and study statistics. How do you write? Learn how to write a girl means what? G and remember intersection study statistics. So you write down already. Okay, a boy and study statistics. Boy and study statistics. Studying statistics studying statistics can be what? Boy or girl. This is the one that I want you to take note. It never mentioned whether it's a boy or girl, right? It just mentioned statistics. But both gender also study statistics. So this is the one that we are applying here. Bayes' theorem. So how do you write? PT, because T is statistics, right? Now remember, if I want to write down the formula PT, it can be what? P, study statistics. If it's a girl, condition is a girl, or plus study statistics, even he's a boy. This is the one that is theorem. So you must consider the two conditions there. And the last one, a girl, given that, see the word given that. So how do you write? Which one is your condition? Given that study statistics. So the condition must be what? G here, right? Given that it is a girl, so G here. So how do you write your formula? P, G and T divided by what? PT here. PT, remember PT, you get it from here, right? Your part 3, part C. You calculate the PT here, then you put inside here. If PT wrong, this one also wrong. Okay, so let's say we look at the tree here. Gender. Getting girl is 0.6, getting boy 0.4. Second condition, second stage here. Girl study statistics is what? Girl study statistics is 0.1, right? So what's our joint probability? 0.6 times 0.1, 0.006. Anyone cannot follow? Alright, this is your condition here now. Now, a lot of people, they don't know how to write this one. Now, mind, I tell them, in an exam, you panic already, you don't know how to write which one already, right? Condition, or event. Yes, a lot of people like that, exam panic. Don't worry, you just make sure this is correct, 0.6. This one, study statistics, if it's a girl, you just write down 0.1. And then the joint probability multiplies by 0. Is it that very difficult? Alright, okay. Now let's say the second scenario. Don't study statistics. This one T, this one must be T bar, right? Right? Now, if it's a girl and don't study statistics, this one 0.1, you know how I get 0.9? How do you get 0.9 there? 1 minus 0.1. What did I say? Complement to every branches, nothing more. Every branches, I don't care 2 or 3 or 4 or 10, the total must always equal to 1. You see this one, 1. This one also 1. This one also 1. Every branches, the total probability must equal to 1. Don't forget that. So this is 0.9. Now, if you want to write the symbol, I advise you can you learn how to write the symbol. So this is girl, condition is a girl. So you don't take statistics. So 0.9 or you just write 0.9 then you multiply 0.6 times 0.9 is 0.94. Understand? Okay, now we go to the second scenario. Now we talk about boy now. So the condition is boy. Study statistics 0.25, right? Given. So the first branches 0.4 times 0.25, 0.1. And if the second scenario, second stage is the boy don't study statistics. This one 0.75, 1 minus 1, 0.25. So the joint probability is 0.4 times 0.75, 0.3. Can I find that this type of question quite, if you understand you can score, right? You can score it. So let's answer the A. Can you get this answer? Try it here. The first one, G and T. It's a girl and study statistics. So how, which one you choose? G and T. Just choose G and T, this one 0.06 only. The second one, boy and study statistics, which one? B and T, 0.1. And then PT, as I mentioned earlier, it can be from boy, it can be from girl. So here now, so T should give us T should be here. So look at the T condition G 0.1 plus T condition G. Sorry, T condition boy. Here, it can be probability from study statistics and girl plus probability study statistics and boy. So T and G, this one 0.06 plus T statistics and boy 0.1. So that will give us 0.16. Am I right? So here actually I'm just telling you the condition here. Now you can write here PG lah. Don't forget you have to times PG. I mix up the G here. This one times PB. Because this one condition B, so times PB. This one condition G, so times PG. Alright. You get back T and G. This one T and B. This is what I write here. Everybody look here. So last one, G condition G. G condition T. So I actually write down. We have girl and study statistics divided by PT. Girl and study statistics is 0.06 divided by 0.16 here. So what do you get? Divided by 2, 3. Divided by 2 is 8. 308 is how much? Is it 0.375? Yes, okay. You can either answer in fraction or decimal point now. Any questions? So you see how you play along or you take 1 hour and play along with this formula. The example. I think you stick so you can drink all the day. Tomorrow exam all log in one. Calculation is like that one, no? You just play around with the number. But if you subjects you have to memorize, don't you know? You have to memorize. Okay. All right, let's look at one more example here. Now see the answer given to you, but in exam nothing given. So if you think that question can be solved using tree, most likely the question will ask you to draw like this. Draw a well-level tree diagram, and then you know it's a tree. But certain question they don't ask you to draw. But if you think you want to solve it using tree, if you think you solve by using tree, then go ahead. But those questions mentioned like this one, then no choice, you have to draw tree, you don't go and draw a square. Which is a table, last method we're going to learn. So here it says that manufacturer purchase component from three suppliers ABC. This is the one I mentioned here. We have 3 bunches now. 0.3 for A, 20% from supplier B, 5% from 50% from supplier C. So together 100%. See bottom of that. It is done that 3% of the component from A, 5% from B. Is it noisy? No, I cannot. Can do that. Let me write the resolution now. 2% from C are defective. So let's call D is defective. B is defective. A means from supply A, B from B, C from supply C. Alright. So what does that mean? 3%, 5%, and 4%. The probability given that it is defective, you get the supplier from A is 0.03, 0.05 from B, and 0.04 from C. So how do you write that up? Okay, this is your definition of probability. So if you get it from supplier A, you get from B 0.03. So it's mentioned that the condition is A now. So the PD so A is 0.03. Now, if this is D, this one must be D bar. Right? So how much? This is how you write A condition from supply A. The body get to get the non-defective, the D bar 0.97. Again, 1 minus 0.03. Again, someone. So the form just already you know how to do PA and D times 1 times this one. And then the A and B bar 0.3 times 0.97, 0.291. Okay, let's look at one more. If it's from supplier B, the condition and get the defective one is 0.05, right? It's given in the equation here. So to get from supplier B with non-defective 0.95, 1 minus this. So this is your PB and D. This is PB and D bar. And the last one, as I said, you don't worry, you don't have to write, just write number only. Oh. And the last one from supplier C, effective 0.04. This is your C and D. And condition supplier C, non-spot 0.96. 1 minus this. This is your C and D bar. Okay, let's answer the question. I only answer one for you. Okay, the rest you do yourself. From B and defective, this is the easiest one to do for you. So how do you write? B and D. You learn how to write symbol. B and D. So which one? 0.01. Okay. The rest I'll give you 1 minute. If you have any of you have any question, you can type in the chat box. If you cannot get the answer, we will help you to get the answer. So the answer here. B, defective. C, from B, given that, given is a condition. D, from B or defective. From B or defective. Now, you see the word or? From B or, remember you write this, D. Now, remember what rule we use here? Can you see the or, what rule we use? Addition rule, right? Before you use the addition rule, you must check, is it mutually or non-mutually? Can it happen B and D together? Yes, right? So supplier B and effective can happen together, right? So you need to minus back the B and D is non-mutually. Anyone have any problem? You can type in the chat box. I need help. So far, anybody need help? Nobody. And Kenfu, what is the D question is? Have I answered you the D?
Yeah, already answered.
B or D or addition rule. It doesn't matter whether when you see the question involve tree or using table later or whatever. You see the word or means you remember addition rule. You just have to think whether it's mutually or not mutually. Today is double of last week 10, today 20. Next week 30. More and more already. We all got the third booster already, injection. The booster better get third one now. So far the final exam 0 face to face, right? No, not online, right? No news yet. So look at the booster, try to get it. Okay, so far no questions from anyone yet. I believe you're already clear there. If you want, I can write down the symbol, the defective. Defective means what? D, PD. PD. Defective can be from where? See your tree here. Defective can be from A, and defective can be from B, supplier, can be from C, supplier. So you need to add these three together. How do you write? A and D plus B and D plus C and D. This is what I call Bayes' theorem. They don't care how many suppliers are there, as long as they can give you the defective, you must consider all and add it up. Okay, everyone, I think you can write down. C from B given that is defective. So how do you write? Defective is your condition. You want to get the D. So C and D divided by PD. PD you get it from the part B. Again, your part B wrong, your part C also wrong. Okay, no questions. We'll continue with the last one, contingency table. Okay. So you can try a tutorial 3. I think the last part is about 3 diagram. Finish it. Then you get your passive questions. Anyone get passive question? I think in your tutorial lecture, so your lecture classroom got passive question. You know that your GC got passive question. Your CC already posted some passive a few sets. Try to get not enough, then go and find from the website. IEC website. Okay. Do study or whatever. We may not have time to do revision at the end of the semester. So after every lecture finish, go and do your passive. Right, contingency table. Now, this one is also similar to 3, but the only thing is we present it all in the table format. So this is the table, and then this is all the possible outcome. Okay, for one variable, which are listed as a row as well as the column. So we call it each cell, the value entered each cell as the observed frequency, and then we can also call it joint occurrence. Joint occurrence means, now you see, let's look at this example, and then I explain to you what's called joint occurrence. Now you see here, this is about 200 customers, and then electrical store, okay, according to age and gender. So you see, this type of table usually they present your data based on something, whether it's horizontal. Horizontal means row, row, and then the column will be your gender. Let's say it can be anything. When you do your question, you can see different type of variable. Some present as a row, some present as a column. So in this case, gender as your male and female column. The age under 30, we call it U. We use a symbol, and then 30 and above, we call it O. Male, we use M, female, we use F. Why we use symbol? Easier to write. It's simple now, right? Okay. So you see the total here. 140, 60. And then for the row, 60 plus 50, 110. 80 plus 9, 10 is 90. So the total here, this is your grand total. 200 must tally with this one. Okay, this is how we check tally. Okay. Now, what's the meaning joint occurrence? Joint occurrence means, let's say I ask you, if this is a female and below 30 years old, joint means I consider 2 factors. Below 30 years old, let's say, and female. So how many of them? 50 joint. Okay, another example. It's a male and above 30. Male and above 30. So you see the word and, that means you have to look at 2 conditions, male and above 30. So this is the male, above 30 is 80 of them out of 200. Always from the total of the outcomes. Okay. All right, now, a person is selected from the 200 customers. Find PM, PF, PU, PO. Can you find this answer now? Example, PM. I just show one. PM is what? Male. So male is 140. They don't say whether got below 30 or above 30. They never mention that. They just want to find male only. So you don't care. You don't care where, how is the age. So you just take total 140 divided by 100. So that we give you 2 over 10. 7 over 10. PF, PU, PO. So PU, they don't say male or female. You just take the 110, which is the total of under 30. Right? This is the observed frequency. Unless they mention joint occurrence, how old and what's the gender. As I mentioned just now, you have to look at both sides, row and column. Okay, part 2. M and U. This is what I mean, no? M and U, two conditions, male and under 30. How many? 60 or 200. I just show you all one. 60 over 200. So we take 2 divided by 2 is 3 over 10. F and O, MOU. Okay. MOU, this is what? Addition rule. Whenever you see all, first thing in your mind must be addition rule. So PMOU, I just write down here. You can write here, no, sorry, no space really. MOU, right here. You can write PM plus PM. Now, can it be man, male, and under 30? Yes, can happen together, right? Under 30 and male, yes. So you must minus back the M and U. This is non-mutually. Anyone have problem part 1 and part 2? Look at the chat box. Anyone have so far? No question. Yo Dong Ho. Explain me. Oh, this one. Okay, part 3. Let's discuss 3 first before we go to B. U condition M. This one you know. So I try one for you. P condition is M. Find below 30. So U condition M. So this is how we write here. U and M divided by PM. U and M is 60 over 200. Divided by PM. PM is the male. 140 divided by 200. Which we done in part A. So 200 and 200 cancel off. There's 60 over 140. Then you simplify it. Divided by 2 is 3. Divided by 2 is 7. Okay. So the rest M condition U, O condition F, F condition O. Be careful, the right side is a condition. Divided by the condition probability. The rest you know how to see from the table, right? Is the TiUC website okay? Are you using DataPen? Are you use DataPen? Oh, because I find it the TiUC website a problem, right? Anyone use use internet TiUC? Cannot access, right? So I have a lot. Cannot access, right? I see a lot of comment here. Now working slowly. That's how I can access. I also use my DataPen now. That's the problem. Okay, part B, the events each under 30 and male, the M, mutually exclusive. You see, this is what I mean. If you look at past question, there are a lot of questions asking like that. Are the two events independent? Are the two events dependent? Are the two events mutually exclusive? Explain. That's what to explain. How do you explain? Let's say, now we know that mutually exclusive. What's the definition? You must prove what? Go back to your addition rule, right? You must prove what? Mutually exclusive means you must prove the probability. In this case, U under 30 and what? Male, right? You must prove equal to mutually exclusive. The event cannot happen together, right? So the
Sir.
probability U and M equal to 0. Am I right?
Sir.
Who is this?
It's me, Yo Dong Ho. I meant the last question. I meant the question B from the last question, from the example.
Which one? This one?
No, the last page. Yeah, this. But you can continue this. After finish the current question, then you can go back. Yeah.
Effective.
Yeah, this.
Oh, this 3.
You can continue first, sir.
Okay. So now here are the two events mutually exclusive. I repeat, you must prove P U under 30 and male equal to 0. Is this 0? U and M, what do you get? Under 30 and male. We know it's 60, right? 60 over 200. Is it 0? No 0. Not 0, right? So not 0 means not mutually. So how do you write? Since, I don't know where shall I write. I write here, since, therefore, since P, U, and M is 60 over 200, not equal to 0, so not mutually exclusive. Simple as that. Okay, part C. Are the events U and male independent? How to prove independent? Where shall I write? Here. Independent, remember, U and M, if it's independent, must equal to what? PU times PM, right? This is the independent, easiest stuff. There's no condition. So PU and M from our paper, U and male 60 over 200, right? So this is the left hand side. If you prove the left equal to PU times PM, then it's independent. So we know this is 60 over 200. How about PU? PU is under 30, 110 divided by 200. 110 divided by 200. You take, multiply PM. The male is 140 divided by 200. So do you think the answer is the same? Calculator. Please modify this. It's not equal to 60 over 200, right? Not same, right? Left and right. So not independent. So you write down here since not equal, left and right not equal. So you say since then not independent. Okay, so I hope everyone understand how to prove mutually dependent and independent. Follow the definition. Okay, coming back to the B here, what's the problem? Just not move this. Property defective is, you see, a defective can be from a supplier A. So you need to take A and D, and also can be from supplier B. You need to take B and D, and also can be from supplier C. So you have to add it up, these three probabilities. That is the answer B here.
Just now got the question, first formula you gave is the, wait.
You mean this one? This one?
Yeah. The
This one
T
I write
given
here,
G.
actually, this is a condition I write G here times PT and G. Now you see this one PG. Do you know that I add G here already? This
No,
one
I cannot see. I cannot see clearly.
T and G you times with PG. Cancel out. That's why I see get T and G now. This one also plus PT should be I times BB. Do you realize I put BB here times? So you cancel out, you get T and B. So PT is from G and also from Y. I write like this is the same as the T and G. This one T and B. If I don't want to write like this, I use T and G, T and B. It's the same. Okay. I write here already T and G and T and B.
So use the probability of T given G times the
If you are not
G.
familiar, that's why I say everyone, if you are not familiar with this, then you write like this. Okay? Some people don't even want to write, they just took from the tree only. They know from G, from Y. This one they know from A, from B supplier, and from C supplier. But I suggest you learn how to write.
Okay, thank you, sir.
Okay, so these are the condition probability. You must see which condition can give you the event. All must add it up. Okay, so same for the tree, same for the table. I'm sure everyone have known that. This is some of the questions in your tutorial tree. As you can see here, the last few questions, a lot of tree diagram. See here, this is the tree. Draw a tree here, question 8. Question 9, tree also. Question 10, also tree. Question 11 is table. This is the table. Question 10 also table. Question 13 also table. That's it. You see question 13, they ask you, these two mutually exclusive? Explain. This independent? Explain. Spend more time on this because your past question, they always ask, even in the quiz also can be asked. Quiz or test. Alright, so that's the last part of tutorial. So chapter 3. I hope you can do as much as you can. If you have 13 questions here, I don't think enough. If you have done it, you have a lot of spare time, then you go and find your past question. Past question no answer, so you may need to do it, check with your friends, do English study. Okay, so that is for our chapter 3. We take a 3 minutes break and then we go to chapter 4.